Hello guys, welcome back. So in this video we are going to see the Leetcode question that we have seen in the today contest 409. This is 3244, a shortest distance after road addition queries 2. So I have already uploaded the queries 1. Maybe there is some bias issue, but you can see the video. People has already liked the videos and they have used this you can say solutions, right? So I have added into 2 videos, right? And you can see there. So let's continue this video, and if you have any doubt in the other questions, right, solutions, please ping me in the comment box. I'll really help you there. And Expert Funda is always helping students like you who want to go to the product based companies. Okay, let's continue. So question we have here is 3244, shortest distance after road addition queries 2, and the question is saying that we have given integer n and 2D array integer queries, right? So there are n cities, which is number from 0 to n-1. Initially there is a unidirectional road from I to i+1, and for all cities, right, its I is 0 to greater than 0, and it should be less than n-1, means greater than equal to 0 and less than n-1. So queries at I is ui and vi. It represents the addition of a new unidirectional road from city ui to vi, right? So after each query you need to find the length of the shortest path from city 0 to city n-1, right? We have to find the length of the shortest path. So there are no 2 queries, so this is a conditions that we will explain you later in this part of the video. So such that the queries is less than this and less than this and less than this, right? So these are the conditions we have given. So we have to return an array based on these conditions, answer, where I is in the range of 0 to the query's length -1, where answer of I is the length of the shortest path from 0 to n-1. So after representing the you can say graphically, you can see in the program statement is there, right? So some nodes are there, some cities are there, right? And some cities are connected with the unidirectional direction like this. You can see unidirection is only one direction, right? And if you want to find the path, let's suppose 1 2 3 4 5 6 there. So if you find the path, you have to check the path like this, right? So we'll discuss more about this problem, right? So I will tell you that I will guide you that please pause this video and go and read the question properly, see all the examples that we have given, see the explanations. So we'll definitely understand the problem statement, then that will help you to understand the solution. Okay, so first of all, understand the approach and the intuitions, right? So basically this is a shortest path after the queries, right? So condition we have given, but what approach we have to do, what is the intuition behind the solution that we are going to do, right? So initial setup we have to do, some data structure we have to use, and then some how we will do the processing of the queries that we will do, and finally we will return the result, right? So let's suppose initial setup we will start with a simple path that will known as 0 to n-1, right, where each city I is connected to i+1 cities, right? So what data structure we will use? So in the data structure we will use HashMap to keep track of the largest city that can be directly reached from each city. Okay, means we will use a HashMap and we will keep tracking of the largest city. So this help in the efficiency like managing the addition of new roads and updating the path length, right? So after each processing the queries, right, so each query we have what vi and ui and vi, right? So we will update the HashMap and we will include the new road from ui to vi, means there is 2 cities and that we have to include in the HashMap, right? So we will adjust the things accordingly. Okay, so after that, once everything is done, right, after each query we will compute the shortest path length from 0 to n-1, and then we will update the HashMap. So you can pause this video for now and you can try. If you understand the thought, approach, intuition, so you can do what you have to do. You have to think in your mind that we have a simple path that is from 0 to n-1, and every city is connected with the next city i+1, right? And we will keep tracking of the largest city. How? We will use HashMap, and then we can directly reach from each city, and that will help you to add a new road and new roads, you can say, and we will update its length, or you can say path, right? So how we will process the queries? So for each query, what we will do, we will update the has map, and that will include the new road from UI to VI, and so you will have the everything the has map, and you have to process for each query, and you have to compute the shortest distance from 0 to n-1, right? I hope you have understood the intuition and the approach. So let's begin to the next thing what we have to do. So in the steps, I have already told you what is the intuition. Now understand the implementation, how we are going to do implementation. So before doing implementation, what you have to think in the mind, this is the steps to implement, right? So first of all, we have to initialize, right? So we will create an array answer to store the result, right? And what we will do for the has map, we will take integer and integer, right? And that is called nothing but a map, and we'll keep track the largest city that is reachable from each cities, right? Then how we will do the map initialization? We will initialize from I to I plus 1, right? For example, first we will put in the map 0 1, then 1 2, and so on till the n-1 n-2. So each cities is connected with the next to each cities, because it is connected with 1 to next, right? If this is I, this will become I plus 1, means if it is 0, it will become 1, it will become 2, like that we have till the n, and before the n what we have n-1, right? And before the n-1 what is n-2. So this is n-2 n-1, right? I think got it. Next, what we have to do, you have to think how we will going to process each queries, right? So for each queries that we know UI and VI, we will check if CTU is not the map or the largest city from U is already greater than or equal to V. If true, then what we will do, the map remains unchanged, and what we will do, the current size of the map is, we will record it in the answer of I. We'll take an array and we'll put there, right? Then if the largest city from U is less than V, it means we have to update the map, and we will remove all the cities from the map that are between U and V. We will not include V, right? And then what we will do, we will update the reachability of the U to V. Why we are removing these things, right? Because we will not do overlapping, that we will discuss further. So we will record the size of the update of the map like this, and what we will do, we'll update the result, and finally once the result is updated, answer is updated, we will return the answer array, and because this contains what, shortest path from 0 to n-1 after each queries, right? So why is this approach we are going to use? Because it will this approach having a functionality that will efficiently handle the queries, and it will maintain the shortest path dynamically. Each time we will update the has map, because the use of the has map provides faster update and lookup, right? And making this scalable, you can say, for the larger inputs. Even you can put any number of records in the has map. So we have to understand the approach with the key conditions. So there are no two queries such that let's suppose we have given, right, in the condition in the problem statement, right? So this is the condition. No two queries we have given, right? Means queries at I0 is less than J0 is less than I-1 and less than J-1, right? So this means there will be no overlapping or intersecting paths, right? Means if I'll talk about, we have some nodes are there, right? So if we have a path, let's suppose 0 1 2 3, and let's suppose there is a 4, right, like this. So if we have a path, so it means, let's suppose what we are trying to say, so overlapping path, let's suppose we have given 5, n equal to 5, means this is the nodes we have given path, right? So if we want to go from what, 1 to 3, so let's suppose we are going to 1 to 3, okay? So if anybody want to go to 2 to 4, means we are overlapping here, right? Where we are overlapping here, right? So these paths are overlapping, right? Because 1 is less than 2, less than 3, and less than 4. So this query is 0 0 1 0 0 1 and 1 1. It is happening. So no overlapping, means no two queries is the chances, right? So such overlapping is not allowed, right? So this kind of overlapping is happening in your solution, no problem, means this is not allowed in the problem statement, right? So for example, let's suppose how we are going to do no problem and no overlapping, right? So in the same example, give me 1 second. In the same example, I'll use the same example. Okay, so if anybody going to use a path 0 to 2, okay, so if somebody is going to 0 to 2 here, right, and then if anybody want to go to 2 to 4, means he want to go to 2 to 4, so you can see there is no overlapping. So this green color path is not getting overlapped, right? Because once the second path is getting started, it's already the first path is completed. So this path do not overlap because the condition we have given, the path is given, is not satisfied for I and j, right? So I hope you understand the problem clearly, and then you can write the queries, write the exact conditions in the code, right? That is why I said you to pause the video and read the question 2 or 3 times. Because see, today what I done, when it was a contest, I tried to implement, but I have not gone through all the things. So you have to understand the overlapping, right? How the overlapping working here. So let's continue the video. So you are already aware of the non-overlap things. So what we have to implement, same we have to do like that, and we have already talked about this. So if u is not in the map, then it is the largest, right? That we have to think. So you pause the video and see what we have to do, because we have already talked about the overlapping. So you have to just pause this video and you have to go through this. Okay, let's understand the question. So solution, how we are going to implement. So first of all, we have given in the functionality, right, and we have given and queries we have given. Give me 1 second, let me change the color of my pen. Okay, so you can see we have given n and we have given queries, right? So we will create a result, that is answer, and we will store this answer for each queries, right? That we have already written the comment, right? Now what we will do, we will map this, we will get a map and we will store all the reachable nodes, and we will find the largest node, right? And what we will do, we'll initialize the hash map with its immediate successor, means I and the I+1 node, right? Next node. Okay, next node, you can say next cities, you can say. So you will store all this value here. Now we have to process the queries, right? The first 2 steps is already done. Now we are going to be the third step. So what we will do, for each step we have one u and other is v, right? So query at I at 0, we will get what? U. At 1, we will get v. So if u is not in the map, right, or its range already include v, the map size remains the same, right? We will not do anything because map already contains u, and if the map of u is already greater than equal to v, means you can say we have to exclude this, right? It is already included, so we will exclude this. We will continue, and what we will do, we will answer at I, we will make the size map.size, and we will continue. Now what we will do, we will remove all the nodes from u and v, and it will not include u, right? Because if it is in the map, if it is not in the map, then we will do this activity. If it is in the map, then we will remove all the nodes from u and v, and then we will make a new thing, right? So you will get map.u, we will get that this is a end, we will get, and end is less than v. Then what we will do, we will update the end. How? Map.remove we will do, and we will update this, right? Now what we will do, we have to update the range again for the map, right? So what we will do, we have already removed from the this map the value, and then what we will do, we'll again put this range, means we will update the range for u, right? And finally we have our answer at I. So answer at I will store the result, which is the current size of the map, right? And current size of the map is nothing but your result, right? So you will find the shortest distance and will return answer. So this is the answer we required here, and that is why we are storing everything, all the size, and then we are returning here. Okay, I hope you enjoy this video and you like this video. If you have any doubt in this video, please hit subscribe this channel, and if you have any suggestions, please put me in the comment box. Thank you guys, thank you for watching this video.
Thank you guys, thank you for watching this video, and if you really like this video, please subscribe this channel. And